deems as at least newer information. Some of today you've done before as well. Because today we're talking about circumference. That's the word I wanted to say. We're working with circumference and arc length. And circumference, the distance around the circle, is something that y'all did actually in like elementary school, if I'm not mistaken. They talk about circumference a little bit back then. Now, not everyone remembers what a circumference is or what the formula for circumference is. Does anyone by chance maybe remember? It's close to pi times radius. What did you say?
I just said the same thing.
Okay. There's actually two formulas for it. Diameter times the radius, which they actually tend to write actually pi times d. I don't know why I did d times pi. So d is diameter. Now d is a lowercase letter, indicating it's something that you could, if we were working in the real world, just take a tape measure to. Remember that? Mentioned it yesterday. C is a capital letter, indicating it's something you would typically calculate because you can't really take a tape measure and put it around a circle very well. In 3 dimensions, honestly, you probably could to a point. Like I could wrap a tape measure around this, but it doesn't work beautifully all the time. The other formula is built on this. Has to do with the radius. How is a diameter related to a radius? Double it. The radius is half the diameter, or double the radius and you get the diameter. Which means I can take this d and replace it with 2r. And generally the order they do is 2 pi r. R being the radius. So, you might be asked to find the indicated measure, indicating that it's not always going to be circumference they're looking for. Sometimes they're going to be working backwards. By the indicated measure, it can be either exact, in other words, that would be in terms of pi, or we can round to the nearest hundredth. Now, I want to show you both because of the fact that standardized tests will oftentimes give exact answers. And oftentimes they do like this multiple choice thing where you have to figure out which one is the correct exact answer, and you need to be able to at least recognize the exacts. On the test, on the quiz, if you want to put the rounded to the nearest hundredth the entire time, I'm okay with that. But I need you to have at least seen these exact answers in terms of pi answers so that as you move forward and in the future, if you take a standardized test or in college, sometimes they require you to exact, I want you to have at least seen it. Okay. Circumference of a circle with a radius of 9 centimeters. Now, just to read these correct, it says find the indicated measure. The indicated measure in this one is the circumference. That first word is generally telling me what I'm looking for. Okay, so I'm looking for the circumference. I'm given the radius. Which formula makes more sense to use?
The bottom one.
The bottom one. Circumference equals 2 pi times 9. An exact answer, you plug the number in, you simplify the numbers. Just the regular numbers, I should say, because pi is technically a number. What's 2 times 9? 18. So this would be 18 pi. Circumference is going to have what kind of units on it?
Oh. Centimeters.
Centimeters. It's a measure of a length around a circle, but it is a length or a distance. So 18 pi centimeters would be the exact version of the answer. If you don't want the exact version of the answer, you're just typing it into a calculator, but pi is not 3.14. pi is close to 3.14, but it is not 3.14, which means when you're typing it into a calculator, you need to find the pi button. Some calculators, it's really, really easy to find the pi button.
Yeah.
Because these little TI calculators, or a lot of little calculators, it's just a button along the side. I'll eventually find where I am. Right there. That's the pi button. On the bigger calculators, it can be a little bit harder to find. By the way, y'all might want a calculator. Grab one if you don't have one. On the bigger calculators, pi tends to be a secondary button. In other words, since my TI has blue as its second button, I'm going to look at all the blue on the calculator. On my Casio, I've got a gold under my shift. I'm going to look at all the gold. And on the TIs, it's right here. It's above the power button. On the Casios, it's way down at the bottom on the EXP button. So, once I know that, then it's just typing it into my calculator. 2, hit the second or the shift button to get your pi on these ones, and then times 9. And if you have a fancy calculator, it'll give you the exact answer. If you have a less fancy calculator, or if you want the decimal version, click the little F to D, and it'll change it to the decimal form. Round it to the nearest hundredth. What's it going to look like?
56.55.
56.55. Again, on a test or a quiz, I do not care which of these answers you give me. I will tell you right now, exact answers will only have integers or fractions as the number. Simplified fractions. So, if you type in, if this wasn't a 2 and a 9, if this was an ugly decimal and you typed that in, you wouldn't be doing exact. In fact, general rule of thumb, if that's not a whole number, give me the decimal version. Okay, problem B. Circumference of a circle with a diameter of 12 inches. Use the top one. Circumference equals pi times 12. As an exact answer, numbers come before pi, and it would just be 12 pi. Units? Inches. Yeah, when it's exact, if I give you a diameter or a radius that is an integer, a whole number, it's super easy just to do exact.
Will you give us 50 ones?
Some of them.
Okay.
Things, if they're not nice numbers, you just type it into a calculator. Is typing it into a calculator particularly hard?
Perchance not.
Sometimes.
Nah. What, typing that into a calculator? No. So, round it to the nearest hundredth. What's it become?
37.70.
37.70, because the 9 tells the 9 to round up, and when a 9 rounds up, it rounds the next number. Don't forget your units. Okay. Radius of a circle with a circumference of 37 meters. This time I'm looking for the radius. Which formula makes more sense to use? The bottom one, because I'm looking for the radius. I was given the circumference. This is my formula. I plug in what I know. I know that's 37. I solve for R. How do I solve for R?
Don't say it.
Yes, you do.
Divide by 2.
Yeah, start by dividing by 2. 37 divided by 2 is 18.5. Now what?
Divide by pi.
Divide by pi. Dividing by pi will never give you a nice number, so it's always going to be a decimal at that point. 18.5 divided by pi. You have to give me a decimal answer when you're dividing by the pi. 5.89. It's a radius, so meters. Still nothing too crazy?
Nah. Wait, why do we put it like that?
Why do we put it as a decimal?
No, in the French.
Because I had to divide by pi to get r alone? Because it was being multiplied? Okay. I don't know why I was putting that there. What am I looking for on D?
We're looking for the radius and or the diameter.
Not and or.
Well,
And. Diameter and radius. Which one makes more sense to find first?
the diameter.
I would go with the diameter. Does it make that big of a difference?
No.
No. So, circumference equals pi times diameter. The circumference I was given,
14.
not 14,
14
it's
pi.
14 pi. Keep an eye on that. That's what the standardized tests like to tend to do. To get to the diameter alone, it's being multiplied by pi. How do I do multiply?
Oh.
Divide by pi.
This is 14.
Pi's cancel out. Diameter is 14 what?
14 millimeters.
Millimeters. If the diameter is 14 millimeters, what's the radius?
7 millimeters.
7 millimeters. Because diameter is 2 radii, or 14 equals 2r. You don't have to write that full thing out, but okay, what if I give you a word problem?
We got it.
You do have it. In a 26-inch bike, 26 refers to the distance around the circle. In other words, or sorry, not around the circle, across. I can read.
Oh,
Across the circle. If you go all the way across the circle. In other words, diameter is 26. What is the circumference?
We don't know.
We don't know, but we could calculate it, right?
Yeah.
Circumference equals pi times diameter. Pi times 26. As an exact, it'd be 26 pi. What's? Inches. As a not exact, 81.68. Question for you. Honestly, I would be perfectly okay with either of these. But if this is a word problem, which one actually makes more sense?
The right one?
The one on the right. Because if someone came up to you and said, I wonder, if I've got a 26-inch bike, what is the circumference of its wheel? You answered them 26 pi, they're giving you a weird look. Work, but... Okay, page 1. Nothing too crazy. Page 2. We're also talking about arc length today. Arc length also has two different formulas because an arc length is a length of an arc. It's a part of a distance around a circle. Have we heard something like that before?
Chance.
Part of the curve of the circle? Dealt with that in chapter 10, but that was arc measure. Arc measure and arc length are not the same thing. Those are not the same thing. I'm talking about arc measure. I'm talking about something where I'm doing like the measure of AB, and this will be in degrees. Arc length, on the other hand, wow, I can spell length, don't mind me, I put a D there instead of a G. Arc length is part of a circumference. And if I take part of a circumference, for example, let's talk about the bike. The bike had a circumference of 81.68. If I want part of it, let's say I want half of it, I'm getting a little over 40. What kind of units go on an arc length if I'm taking something that was 81 point something inches and I'm taking half of it? It's still in inches. Could be inches, could be meters, could be centimeters, millimeters. I could go on forever. There's a lot of different things I can measure it in, but the point is it's measured in the same way a length is, with that kind of a unit. Now, being part of a circumference, really, the formula itself just tells me, well, how much of the circumference do you want? If I want half of the circumference, circumference is pi times diameter. If I want half of that, I put a half in front of it. If I want a quarter of a circumference, I put a quarter in front of it. How much of that we do depends upon the central angle that corresponds with the arc that we're looking for the length of. Now, arc length, they use a lot of different possible variables for it. I'm going to do a capital L. L equals. So the first thing I need is I need the fraction. That fraction depends upon the central angle. If I go a full circle, a full circumference, what is the central angle of a full circle? 360. I want a portion of it. I want x parts of it. So the first part of this is x over the full 360. How much of it over the total? Thank you. And I multiply that by the circumference formula. Pi times d is one option. Or x over 360 times 2 pi r. X is the central angle, specifically of the arc that we're wanting. D is diameter. R is radius. So, find the indicated measure, round to the nearest hundredth if necessary. Arc length, very, very rarely will you get a nice exact answer, so generally we tend to round. I want to find the arc length, not the arc measure, the arc length of arc AB. Okay. Which formula makes more sense to use? Why the bottom one? You don't have a diameter, but you do have a radius. What's the radius? 8. So, arc length equals x. What's x? 60, because that's the arc we that's the central angle to the arc we want. Note it better be a central angle, meaning it's an angle where on the circle? At the center of the circle. it's not at the center, we got a problem. So 60 over 360 times 2 pi times 8. Now that might not look pretty, but it goes into a calculator just fine. 60 divided by 360, I tend to put fractions in parentheses, times 2, times the pi button, times the radius, 8.38. Units? Centimeters. Try out B on your own. Be careful, make sure you're getting the right central angle. You got 5.89, you missed something. No, it would have been 8.9 had you rounded it. But everything except for the second one? Yeah. Well, you said it backwards, but yeah. That's not right. For two reasons. First of all, you shouldn't have a 75. Because 75 is this one. Second, you shouldn't have a 2 here. Question for you. What's X?
X is approximately 285.
Where are you getting 285 from?
You're taking 360 minus 75.
The arc that I want goes from P to Q, hitting S along the way. Yep. So I want this. So to find the central angle corresponding to that arc, this is a 75. Full central angles add up to 360. 360 minus 75 is indeed 285. 9 was the diameter, so 285 over 360 times pi times 9, 22.38. Have to be careful, make sure you're getting the correct central angle that goes with it. The problems C and D work backwards. They're solving for a radius and a diameter or for an arc measure. On C, do you notice this 10.5 here? Do you notice how it's right next to the edge of the circle? Do you notice that it's in feet?
Yup.
Which means this is a,
Circumference.
no, arc length. That's an arc length. If you see something measured in feet, meters, centimeters, inches, etc. on the edge of a circle that's divided into parts, that is an arc length. The 150 is an X, a central angle. I need both the radius and the diameter, which means I can work with either formula first. Which one's going to be slightly easier to work with?
Diameter.
The diameter one. And if you have the diameter, is it easy enough to get to radius?
Indeed.
Yeah, so we're going to use that one. L equals X over 360 times pi times diameter. I'm just putting it back on screen. Okay, L, 10.5, equals X, 150, over 360 times pi times the diameter. Solving for the diameter. I need to get D alone. It's being multiplied by pi, it's being multiplied by a fraction. I would deal with the fraction first. If it's being multiplied by a fraction, to undo multiply, you divide, but what is dividing by a fraction look like?
Not good.
To divide by a fraction, you multiply by its reciprocal. What's the reciprocal of 150 over 360? 360 over 150. $10.5 times 360 divided by 150. 25.2. I want to get the diameter alone, so I divide by pi. 25.2 divided by pi. 8.02 units. It's diameter feet. How do we get to the radius? Diameter is 2 radii, so divide by 2. Radius of 4.01, also feet.
On the, when you had 10.5 is equal to 150 divided by 360 times pi times d, could you have done the 150 divided by the 360 times by the pi, and then divide the number was
And divide by what you get there?
Yeah,
Yes.
'cause I
You
had this-
could technically simplify this first
'cause I
and
had
then
this
divide by it.
so-
You might get a little bit further off in the rounding. That's why I tend to do it this way. But typically I have both answers written down. Okay. So, last one on this page. I'm looking for the measure of the arc, RS. Does measure of an arc go into either of these formulas? No, but how is a measure of an arc related to a central angle? They're both degrees and? You know this. If this is a 60-degree angle, what's the measure of this arc?
We know, it's the same.
It's the same. Central angles are the same as the measure of arcs. So if I find the central angle, I've found the measure of the arc. So I'm solving for x this time. Top formula or bottom formula? Bottom, because I'm given this, which is a radius. I'm given a radius. What's the 44 meters?
That's the length.
It's an arc length. L equals x over 360 times 2 pi r is the formula I'm working with. L is 44 equals x, I don't know. over 360 times 2 pi times 15.28. Now there's a couple different orders that I could do. I can start by just moving things around, or I can simplify first. Doesn't really matter. I have to get rid of all these things. Because it's multiply and divide and those go together in PEMDAS, then the order in which I remove them doesn't really matter either. What do you want to get rid of first? The fraction? Okay. But here's the thing, I'm not going to multiply by the reciprocal. You multiply by the reciprocal when you're trying to get rid of the entire fraction. Do we want rid of the entire fraction if x is in it? No, and it's on the top where we want it to be. We want f variables either on the top of fractions or not in fractions altogether. So the only thing I'm actually getting rid of is the divide by 360. Multiply by 360. $44 times 360 is 15,840. X is getting multiplied by 2 pi, which is getting multiplied by 15.28. I personally would divide by 2. 7920 equals x times pi times 15.28. I'll be honest, I do pi last. Divide by 15.28. It's not a pretty number. So I just tend to leave it into my calculator and then I just start dividing by pi. If I round at that point, that's okay too. X, my central angle, rounded to the nearest hundredth, 164.99. Central angle is the same as the arc. So 164.99, what's the units?
Meters.
It's an angle, degrees. And if that's the angle in degrees, that's the measure in degrees. Guess I didn't need the degree on that one. I could have put it on this. Okay, last thing you're going to see today. Comes up on the next page. Sometimes you might see some word problems or you might see some composite figures. But you have to be careful. This is composite figure perimeter, not composite figure area. Composite figure area, you find all the area of the individual pieces, you add them together. Composite figure perimeter doesn't work that way. Perimeter is what?
The outside area.
The outside distance of the shape. If I thought about this as individual shapes and each of their outsides, I would have, there's a lot of different ways to break this up. One way is to break it up there, to break it up here, to break it up here. This is the way my brain went. It's okay if your brain didn't go there. So I've got a triangle, a rectangle, and another rectangle. But if I find each of their perimeters, is the perimeter of each of those shapes only on the outside of the composite figure? No. I've got some overlapping sections here that are on the inside, some overlapping sections here that are on the inside. So finding the perimeter of each individual shape is not helpful. It's going to give you things that are not on the perimeter of the actual shape we want. The perimeter of the actual shape we want, of the shaded figure, of the composite figure, is only along those edges. Here's the thing. Do we have a distance for all of them?
Yes, we do.
For all of them.
Yes, we do.
Yeah, we do.
Yeah, we do.
Yeah.
Because there's tick marks
Yep.
for the one that's unmarked.
Come on.
Just add them.
Indeed.
Don't find the perimeter of the individual shapes. Just go there. Thank you. Just add up the ones we know. This unmarked one is a 5. I'm going to start with it. Plus, go around the shape so that you don't lose track. I tend to go clockwise. So I'm going to do 5 plus, 7 plus, 6 plus, 5 plus, 10 plus, 15.
48.
I already added the 5. $48?
Yup.
48 what?
Inches.
Inches. Don't make it more complicated. I want the perimeter of this one. I need this length, this length, this length, this length, and this length. I don't know of all of those right off, but I have enough information to know all of them. That's 4. What's from here to here?
6.
Where's 6 coming from?
The 3 meters on the inside is just the radius, so times it by 2 gets you your diameter, which is 6.
That's a radius, that's a radius. Put them together, that's 6. Do I know this one?
No.
No, but do you see the right triangle?
No.
Do we know this thing?
Yeah.
Yep.
What's that one?
That's 4.
4, because this is a rectangle, so opposite sides are congruent. So I could call that x and do Pythagorean theorem.
Yeah.
4 squared plus 4 squared equals x squared. 16 plus 16 equals x squared. That's 32.
It's not a 30.
What?
It's not a 30 number.
No, it's not. But what are we rounding to?
Near. Oh.
Nearest hundredth. 5.66 is that distance. And then I've got this piece. Would you agree with me that that's an arc?
Yeah.
So I need to find the length of that arc. I'm going to call it L. L equals, what portion of a circle is that?
180. It's a semicircle.
It's a semicircle, so 180 out of the 360 degrees times, I've got a diameter or a radius. I'm going to do the radius one. 2 pi times 3. .42. So if I want my perimeter now, because now I have all my lengths, I just add them all together. I start at 1, I go around the shape. I'm going to start at this 4 and go clockwise. It's 9.42 plus 5.66 plus 4 plus 6. $29.08. Meters. Okay. I'm talking. Doing great English today. I've talked long enough. We're not going to do the bottom 2 problems.